So happy to start anywhere. Who wants to give us the first question? Okay, there you go.
What's the equivalent of DPMS job for Postgres?
So what's the equivalent of DPMS job for Postgres? So I think I'll let Dennis Lucier help I answer that.
There's PG agent, and version 4 of that has been redone, so that's a separate daemon. So it's pretty good. Is this on? Hello, hello. So there's PG agent, and version 4 of that is actually pretty good and modern. We're working, my own personal favorite is PG cron. So PG underbar cron. We're actually in our roadmap, so for later this year, we're going to try to incorporate a derivative of that into Aurora Postgres that fixes some security stuff and so there's a little bit of engineering that we need to do without using that directly. But you can use PG agent, PG cron like separately if you were running Postgres by itself, and we're interested in that as well. Separately, we're working on another feature, which is integration with what do you call them? The serverless stuff with Lambda functions, right? So that from PL SQL, you can call Lambda functions. So a lot of the kind of things that you're doing with these scheduled jobs and stuff like that, if you had a trigger that you could kick off something in Lambda, you wouldn't need to do that as much. And other people are using, application server scheduler, stuff like that, so to kind of do that out of the tier. So scheduling in the long run, I don't really like doing it in the database, but we are adding PG cron, and those are the other options, as far as I know.
The agent's on AWS now?
Agent is not on AWS now. So those are the two community options for doing that, PG agent and PG cron. There's probably a couple more, but those are the two that have my attention.
Yeah, so to be clear, you could use PG agent and PG cron if you're running self-managed Postgres on EC2, but we haven't incorporated equivalents into RDS or Aurora yet. Yes?
But we will soon.
How do you handle connections greater than 200, meaning number of connections greater than 200? So you can throw hardware at it and just scale up to a bigger instance, which is kind of the flip answer. So for those of you who don't know, Postgres has a process per connection model. All right, so every connection to a Postgres instance, whether it's self-managed or RDS or Aurora or on-premise, every connection causes the Postgres instance to spawn a separate OS process on the database host, which takes up CPU and memory and other resources. You can control how much memory each connection takes with various parameters, like workmem, for example. And in some cases, you want workmem to be bigger, because you might be doing big sorts. You might have queries that are building indexes or doing queries on large tables with group bys, et cetera. But if you set the memory parameters big, then that means that you're going to run out of memory when you have a larger number of connections. You can set the memory parameters smaller, and you'll fit more connections at the cost of whether, it might be cost of performance based upon what that memory might be used for. A lot of customers, when they want to support thousands of connections to a Postgres instance, will usually put a pooler in front of it. Either PG pool or PG bouncer are the ones we typically see. Today in RDS and Aurora, you need to set up your own connection pooling, meaning a lot of customers, they'll set up a separate EC2 instance with PG pool on it, point their apps at PG pool, and then point that configuration at the actual running instance. That means you have to run your own pooler. And so we've gotten lots of customer requests to build some sort of managed connection pooling into our managed Postgres instances. And we are looking at that. We have some ideas on how we can solve that problem. It's not solved today. Having said all that, we do have customers who throw hardware at it. The biggest instance we support in the R4 class has almost half a terabyte of main memory. We're adding support now for the R5. It's already available in some regions. The R5 24XL has 3/4 terabytes of main memory. So the question, is that with Aurora or RDS? Both. Well, RDS runs everywhere in R5s already. R5s are being rolled out through the Aurora Postgres fleet now. You'll see it in some regions already. But like I said, you can throw hardware at it if you really need the memory and the CPU to support hundreds or thousands of connections. You can certainly do it. Works a little better in Aurora just because we've done some tweaks to make it scale better.
Can I follow up on that?
Yeah, go ahead, Dave.
So, hi, I'm David Wine. I'm a principal engineer and director of engine development for Postgres. Hi. I'll say that again. I'm David Wine. I work with Kevin. I'm a principal engineer and director of engine development for Aurora Postgres. What Kevin said is absolutely correct. Connections in Postgres use a lot of memory. I will throw a plug-in for Aurora. We did some work inside the Postgres engine around areas where Postgres bottlenecks with large number of connections. And even if you run benchmarks with Postgres, you'll see as you keep adding more concurrent workers, you actually start getting less throughput. So it doesn't even plateau. It really hits a knee and drops off because the contention points becomes so severe that as you add work, it just makes everything slower. We don't have that with Aurora. We in our benchmarks can run up to 4,000 connections. That's not actually a limit. That's just how high I've run them in the benchmark. And we don't hit that knee. You'll plateau at throughput at some point, but in summary, we've done a lot of things inside the engine to remove the contention points with a high number of concurrent users. So Aurora does better with large number of connections than RDS Postgres.
All right, who's next? Great.
Does Performance Insights come with sort of a starter template for best practice monitoring of Postgres that you can tweak and tune to your needs?
So the question is, does Performance Insights come with a starter template or best practices on how to tweak or tune Postgres? So today, Performance Insights, you turn it on for your instance and you start looking at the display and it'll show you just the top SQL. I think by default it sorts by SQL statement by load. And there's different ways you can resort and redisplay the data. Today, it doesn't give any recommendations. It doesn't tell you, gee, it looks like this query is kind of going sideways, you should add an index, or it doesn't tell you anything on the next steps. So out of the box, it will just show you the things that are consuming the most resources. The team that built Performance Insights has all kinds of interesting plans for ways that we might be able to make recommendations and give advice based upon what Performance Insights is seeing. But today that's the baseline. Now, there's lots of blog posts that we put out on things related to, say, Oracle to Postgres or Oracle to Aurora Postgres migrations. And I think there are some on performance tuning in general, but there's nothing built into the Performance Insights tool. Is that what you're asking? Is there something built into the tool itself?
It sounds like maybe the metrics I'm talking about are still in CloudWatch.
Right, so the metrics are still in CloudWatch. Which metrics are you thinking of?
Just like transaction wraparound.
Transaction wraparound.
Ratio, basic.
Yeah, those metrics are more instance level because PI really looks at it. The way PI works is it samples your instance and looks at what's running every second. And so it just sees what queries are running, what they're waiting on. And then it builds up this time model view of your instance over time. And it's only recently that they added counter-based metrics where it actually looks at how many times something has happened, like commits, for example. So PI now is starting to show counter-based stuff as well, but the original implementation was all about just sample the instance, just see what's happening, and then build up this graphical view of what's happening in the instance over time. You can also see why it's easy for PI to store that data. Just has these 1-second samples, just stores it for a 7-day rolling window. But the counter-based metrics is probably going to give more of what you're looking for. So you should take a look because I think we only launched the counter-based stuff like last week. So it's all brand new stuff in Performance Insights for counter-based metrics. Yep.
Does everything from Performance Insights go into CloudWatch?
Does everything from Performance Insights go into CloudWatch? I don't think everything from PI goes into CloudWatch. Enhanced monitoring, the OS stats does. PI does not. PI does have an API. You can pull it out yourself and do whatever you want with it, but it doesn't automatically flow into CloudWatch.
You can choose, no, some of the PI metrics do flow into CloudWatch. The database load does, and then, yeah, some of them absolutely do.
So some of the metrics, but not the individual SQL statement data, right?
Not the SQL statement, but I can't remember if some of the counter stuff might also flow up.
The brand new counter-based metrics may flow.
I don't remember for sure.
Okay, great, thanks.
Regarding AWS plugin. So in Redshift, you've introduced the ability
So the question is about Active Directory integration, which exists now in Redshift. Why doesn't it exist in RDS Postgres and Aurora Postgres? Just because the calendar hasn't moved forward far enough yet. It is in our roadmap for later this year. If you saw me this morning, I talked a little bit about the integration we did with IAmAuth, Identity Access Management Authentication, which we launched for both Aurora and RDS earlier this year. That was a step along the path of making it easy for customers to integrate with their existing, typically on-premises Active Directory domains. And so we are planning to add that capability later this year for both RDS and Aurora. And if you look more broadly at the other RDS engines as well, depending on the engine. The status of Multimaster, we could spend the next 45 hours talking about that. So I'll ask a question back first. What do you mean by Multimaster? So bidirectional replication. That's one way to implement Multimaster. What problem are you trying to solve with Multimaster? Okay. Well, I'll tell you what kinds of problems other customers have told us they're trying to solve. And it really depends. There's kind of two types of Multimaster, or two phases of Multimaster we're working on. So one is what we call Multimaster in region, where, think of the Aurora architecture. You have the shared storage volume across multiple AZs, and you have a read-write instance and a bunch of read-only instances all sharing full access to the same database on storage. Well, what if you could make those instances, all of them, read-write instead of just one of them? So that's Multimaster in region. Multiple masters, one database. How do you make them play nice so that you can do full-on OLTP transactions to the whole database from any master and not corrupt things and not make confuse yourself and your users and your code? So that's the Multimaster in region project. Now that started first with Aurora MySQL, something we announced more than a year ago. And so Aurora MySQL's been running a preview. They have plans to go GA sometime this year with Multimaster in region. Aurora Postgres, we started the whole project more than 2 years after Aurora MySQL, so we're behind them in terms of timeline for delivering big features like Multimaster. Not an easy thing to implement. So our target right now is sometime next year for Multimaster in region. The other Multimaster is Multimaster multi-region, which by definition is not one copy of the database. It's a copy in this region and a copy in another region, and now you've got reads and writes going on in both places. How do you make sure that they don't step on each other when you have much higher latency, right? The latency between regions. And so really the first phase of that project is what we call global database. You can see that already there for Aurora MySQL. And global database, this first phase is simply cross-region replication, where the Aurora storage nodes will replicate or copy their log changes from the source regions to the target region, and there's an Aurora storage cluster in the target that receives the log changes and applies them to database pages and keeps a copy hydrated for read traffic. Initially, it'll be cross-region read replicas. That's a project that's coming sometime this year for Aurora Postgres as well. But the next phase, where it's full-on read-write access from both sides, is something that's generally on the plans for next year for both Aurora MySQL and Aurora Postgres. A lot of details to work out on how you manage conflict resolution in that kind of multi-master, multi-region environment. Now, the use cases that we see for multi-master in region are typically high availability. I want to just keep writing to my database if a node fails. And high availability where even fast failover isn't fast enough. I just want to be connected to and write to one, and if it fails, I want to keep writing to the other. And if it's truly segmented like that, where one of them isn't really being used, then there's not a lot of conflicts to worry about. The other is where customers want to scale writes beyond the limits of even the biggest head node we can give them. Beyond an R5 24XL with 96 vCPUs, et cetera, they have a workload that just has to scale bigger than that. Then they need multiple head nodes, multiple big head nodes banging on the same database. And then they need to worry about segmenting their workload so it doesn't attack the same data at the same time. Because if you do that, if you have too much contention between nodes, it will not scale because you're just going to thrash sending the data back and forth. This node updates the data, then that one, then this one, and that one. So you always need to partition your access in these multi-master environments. So that's kind of the workloads we see for multi-master in region. Multi-master, multi-region, it's usually about latency, low latency for customer access. So those workloads really need to be segmented as well. But it might be where I have customers who, want to access their data in Europe, and I want to have one big database, and customers in the US want to access their data as well. It can usually be segmented well so they're not going to step on each other. If I go travel in Europe and I log onto a system there, maybe my data will, it'll be replicated over, so it'll be available in the European copy as well. But most of the time there won't be conflict. So multi-master, multi-region makes sense for use cases like that, where also they happen to be a DR, disaster recovery failover target. So like I said, we could talk for a lot longer about multi-master, but that's just kind of the high level state of the world for multi-master in Aurora. Other questions? Yeah.
Is there a date for PI in GovCloud for Aurora and Postgres?
So a very specific question. Is there a date for performance insights in GovCloud for Aurora Postgres? There probably is. I don't know what the date is, though. I would guess it's sometime this year, but I don't even want to promise that. I'd have to check with the team. More generally, we are rolling out performance insights beyond Aurora Postgres, where it started, to the other RDS and Aurora engines. And so it's available in RDS for Postgres, starting with Postgres 10 and now Postgres 11. I think we've launched it for Aurora MySQL, RDS MySQL, et cetera. So we're rolling it out across the engines and across the regions, including GovCloud eventually. But I don't know specific dates for when it will become available in GovCloud. Yeah.
Are you able to give us an idea of across the different RDS services, Postgres, Aurora, Oracle, all of those, which are the top 3 or 5, and what's the adoption rate?
Question is about all the RDS engines. There's technically 7 of them. Which are the top ones, what's the adoption rates, et cetera. So, we don't disclose specific numbers about those. I can say that they're all growing healthy businesses. Some people think that, I got this question earlier today, so how do you convince people to move off of Oracle to Postgres? And I said, we don't. If you want to run Oracle in AWS, we'd love to have you. We have a very healthy RDS Oracle business, very healthy RDS SQL Server business. It's just when customers come to us and say, I want to get off of Oracle, then we can help them. But we don't go out there campaigning to convince them they should move off of Oracle. So they're all healthy, growing businesses. What I can say is that Aurora is the fastest growing service in the history of Amazon, or history of AWS. And that was before we launched Aurora Postgres. Aurora MySQL by itself launched in July of 2015, and over the next couple of years became the fastest growing thing we ever launched. Now, it's not fair to measure in the first month of growth, of course. After it gets up to a sizable level, it's been the fastest growing. Aurora Postgres has accelerated the growth, let's put it that way. But they're all growing businesses, and like I said, growing and healthy businesses where if you just look at what we launch for each of those engines, we continue to accelerate the number of services we launch for each engine. That's because we keep on getting more customer demand for new features in each of the 7 engines. So we're not slowing down, we're speeding up pretty much for all 7 engines. More questions? I'm trying to think what questions you didn't ask that you should be asking me. You should be asking me about outbound replication for Aurora Postgres. Hi, Dave. Well, let me tell you, Dave. Let me tell you about outbound replication first. We've talked about it multiple times today. Standard Postgres supports lots of ways to replicate out of a Postgres instance. RDS Postgres, we added support for replication slots, a standard Postgres feature, several years ago. And Database Migration Service sits on top of that feature. When we launched Aurora Postgres, we launched it without any support for outbound replication. Primarily because we rewrote the logging and storage layers, and that meant that we took away replication slots and we had to re-implement that. And we didn't want to wait to get that done to launch Aurora Postgres, so we launched without it. And we've been working to catch up and add support for replication slots to enable outbound replication ever since. And our target is to launch that this year. I can say it's coming pretty soon now, but I can't give you a specific date. But it's coming soon, and it will behave just like it does in RDS for Postgres, with support for replication slots with the same logical decoders that you see in RDS Postgres, and of course support for DMS, Database Migration Service. So DMS will be able to use Aurora Postgres as a source to replicate from Aurora Postgres to wherever DMS can replicate to, which is a whole bunch of different kinds of targets, including things like Redshift or another Postgres instance, or Oracle on premises, which a lot of customers want to do as a fallback. When they migrate from Oracle to Aurora Postgres, they want to replicate back, just in case they think they find a need to fall back and cancel their migration. So the launch of Outbound Replication will enable all of those scenarios and others that our customers will think of that we haven't thought of yet. So that's coming soon. The other feature, will it support PG Logical? Not in the first release, but in a subsequent release, it will support PG Logical. So the initial goal is to support replication slots in round 1, and then add PG Logical in round 2. The other feature lots of customers ask about is a feature I've already mentioned a little bit, what we call global database, but the way customers ask for it typically is, I want to implement cross-region replication. So I can have an instance in a different region to protect myself against disaster recovery, or to provide disaster recovery. And again, that feature is coming. It's what we call global database. It's based upon Aurora storage-based replication. Now you might say, wait a minute, couldn't I use that outbound replication thing you just told me about to keep an instance in another region hydrated? Yeah, we're not going to block you from doing that. We just pretty sure that the performance won't be as good as the storage-based replication that we're working on. And you might find that the lag in your instance in another region, the lag for that instance when being hydrated by the outbound replication that we're going to launch soon, the lag might not be acceptable for what you need, at least for RPO, for recovery point objective, for that disaster recovery copy. Now, it might be fine. Maybe your RPO is not really stringent. In the case of Aurora storage-based replication, we expect the lag to be very, very small. What we're seeing with the same type of replication for Aurora MySQL is lags typically of a second or less for regions that aren't too far apart, like say Northern Virginia to Oregon, which is still 3,000 miles, but the lag is pretty short. So if you have RPO of seconds or minutes, Aurora storage-based replication will easily fit within your RPO requirements. Yes? Right, so the question is, the documentation seems to imply that PG Logical is supported now. That's true for RDS Postgres. If it implies it's supported for Aurora Postgres, then that's a mistake in the documentation, since we know logical replication isn't supported at all yet. When it is, it will be initially replication slots, not the new pub sub capability that you might be referring to, publication subscribe capability. There is kind of one exception. So if you're using the new pub/sub style logical replication, you can't use that to replicate into Aurora Postgres yet, because you actually have to have support for that new capability in the target instance, not just in the source, the way it works in Postgres. And we do plan to add enough support so that you'll be able to use that replication to replicate into Aurora Postgres when we do this initial launch. So it's a little nuance that it's hard to get across clearly in documentation, especially since we haven't launched it at all yet. Do you have a follow-up? With PG Logical, I think you can replicate into RDS. Well, I know you can replicate in RDS Postgres. I don't think you can replicate into Aurora Postgres now. See, Richard's going to correct me. Okay, so engineers have tested and confirmed it works. So I just need to make sure the documentation clarifies that then. Yeah. Right.
We know that we're going to work with Henry to do a better job of documenting how you move from on-prem Postgres, if you're using a sophisticated use case, into RDS and or Aurora.
Yeah. So.
Improve that documentation in the coming months and work with you to make sure that we can do exactly what you're saying. We've got engineers that have done it, so we're going to help to document that stuff better.
Yeah, some of you pointed out, rightly so, that we have a lot of documentation on how to migrate from Oracle on premises to RDS and Aurora Postgres. We have a 350 plus page manual on how to do that, and other blog posts, etc. We don't have the equivalent for how to get from Postgres on premises into Aurora or RDS. We have smaller pieces, but it's not nearly as well organized or coherent, and that's what Dennis is referring to. You know, based upon that feedback today, we're organizing some people to work on that and make that much easier. Any more questions? Yes, you first. When do we expect compatibility with Postgres 11? Well, we already did that for RDS Postgres last week. We just launched Postgres 11.1. And it's coming soon for Aurora Postgres. Slightly more generally, our goal is to catch up to community releases a lot quicker than we have been, both for RDS Postgres and Aurora Postgres. You know, we are working on getting, I think I mentioned this morning, getting Postgres 12 into the RDS preview environment when it makes sense, when there's, you know, a beta drop that we can work with. So, you know, that's typically in the spring from the community. Spring is 3 days away. So it's coming soon, you know. So we do have ideas on how we can do that for Aurora Postgres in the preview environment as well. This will let you start testing Postgres 12 features for your applications, for your environments, before its production from the community. You won't have to spin up your own manually managed beta instance in EC2 or on premises. You'll be able to go to the RDS preview environment, just push a couple buttons, spin up an instance, and start testing. We did that with Postgres 11 in the preview environment for RDS Postgres. We're planning to do it for both RDS and Aurora in the preview environment for Postgres 12. And then when PG12 actually goes GA, but from the community this fall, our goal is to catch up as quickly as we can. It's easier in RDS Postgres. We don't have so much of a merge burden. It's more just tooling and upgrade work. But so our goal is really to be within 30 to 60 days of the community. So sometime late this year. Now we don't always meet those goals. Sometimes things slip, but that's what we're targeting for major version support.
When you launch Postgres 11, Aurora Postgres 11, will we be able to upgrade existing clusters?
Well, gee, Dave. So Dave's question is, when we launch Aurora Postgres 11, will we support major version upgrade from previous versions of Aurora Postgres? Because those of you who are active users know that if you have an Aurora Postgres 9.6 instance today, you can't do a major version upgrade to Aurora Postgres 10, which is kind of not a great experience. You have Postgres 10 waiting for you there, but to get there you have to do a dump and load and take downtime, and it's painful. And you can't even do outbound replication yet to shorten that. And so we are working on adding support for MVU, as we call it, major version upgrade. I believe the timing right now is we'll have MVU before we have Aurora Postgres 11. If not, they'll be about in sync. So, yeah, you know, these are somewhat moving targets, but I think they'll happen at roughly the same time.
They are going to happen just to add a little color to what Kevin said, they will happen at roughly the same time. We believe getting Aurora Postgres 11 so that you could at least be trying it out would be, so we would not, if the MVU that lets you upgrade to Aurora 11 came out a month later than Aurora 11, we wouldn't slow down Aurora Postgres 11. So they're both short-term features on our roadmap that we're, you know, going to be out with shortly, right?
Yeah, but we're not going to hold one for the other, as Dennis points out, because customers will independently benefit from each. So when each is ready, we're going to launch each one.
And we are aware that we need both, but we were getting each
The man in the red shirt.
So, what is serverless for Aurora Postgres, and what can we expect it?
Aurora Postgres serverless. So what is that project? Well, it's functionally the same as Aurora MySQL serverless, which is GA, and there's a whole bunch of doc and blogs, etc. Whatever you read about Aurora MySQL serverless is roughly equivalent to what you'll see with Aurora Postgres serverless. Aurora Postgres serverless is in public preview. You can actually sign up. If you literally just Google for Aurora Postgres serverless preview, you'll find the sign up page. And we're busy whitelisting more customers into that preview. But what is serverless? What is Aurora Postgres serverless? Basically, it gives you an Aurora Postgres endpoint where you don't provision a server. You don't say, hey, I want an R4.4XL and provision all the details of that instance. You basically just get an endpoint that you start creating tables, inserting rows, doing transactions on. And you specify a lower and an upper bound on Aurora compute units, which is really a combination of CPUs and memory. And we will scale up and down between your upper and lower bounds based upon how busy you make your endpoint. And so you don't have to think about, like I said, provisioning and then, oh, wait, my workload's going to scale up, spike, tomorrow, so I need to manually scale up. We also maintain a proxy in front of your instances so that proxy holds your connection state while we actually scale underneath those connections. So when those scaling up and down happens, you don't lose your connections to the instance. So the idea with serverless is it's ideal for workloads that have lots of variability. Whether it's predictable variability, like you know that people are going to be busy on your systems during the day, but you want them to kind of, when your developers stop working at 8 or 9 or 10 at night, you want it to scale down to a lower level that costs you less, and then scale back up when people get busy the next morning. Or you might have a production system that has unpredictable variability. It might be based upon news cycles, and it's an ad server for media, and so you don't know when there's going to be spikes. In both cases, serverless will provide a more cost-effective experience than provisioning for peak in the traditional, what we call provisioned model. Because in the provision world, you either have to provision for peak or you have to plan scaling operations which cause disruption to your application environments, to users who are connected. And so serverless is designed for those unpredictable workloads. And so it's a really cool technology to play around with in the preview. Again, you can see some of the more developed documentation if you look at the Aurora MySQL serverless documentation and blogs. Any follow-on questions?
When will the documentation be ready?
It'll be ready when we go GA, which is sometime later this year. Yes?
So does the application need to be modified for this? Because just looking at RDS session today, where they talked about how the memory is split into, the caches and all that.
So you're asking if applications need to be modified for serverless?
Yes.
No, they don't even know it's a serverless instance. It's still Postgres, or MySQL in the Aurora MySQL case. It still looks just like your normal database endpoint. It just so happens that under the covers, we're automatically scaling up and down the compute resources, compute and memory resources behind that endpoint. But you don't need to change anything. It's not like it's a limited version of Postgres that doesn't support all the SQL dialect. It's just Aurora Postgres where we're doing some, control plane stuff to scale it up and down, and the proxy, of course, to keep your connection state. But no, there's nothing you need to change.
With one caveat, there's no read replicas.
Yeah, good point. Today, Aurora Serverless is just one instance. It does not have support for read replicas in the provisioned Aurora model. Thanks for the reminder, Richard. Doesn't change how your application works functionally, but it does change how you think about scaling, because it currently doesn't have a scale out model. It only has a scale up and down model. Now, one other little quirk in serverless, you can set your lower limit to 0, which means when your instance goes idle, under the covers, we're going to scale down to 0. We'll still hold on to your connections, and of course your storage is there. But what happens is the next time you touch the instance, we have to go provision. We have to grab an instance out of the warm pool and connect it in. There's a little bit of extra latency for that first touch. You might not want to have that latency, so you might set your lowest level to the lowest non-zero level. And so there's a difference in cost there, right? But depends on your workload requirements. Do you care about that first touch slowness or not? If you don't care, then you just let it scale down to 0. If you do care, you scale it down to the lowest level. And on the upper limit, of course, you don't have to set it to the max because you might not want to spend the amount of money it costs to run at the max level. You might know that you have spikes where it's okay for the spikes to get a little bit higher latency because you're not going to scale up to the largest size.
One other point
Yeah.
that Kevin would be built slightly differently too. I don't know if you want to talk about that. I mean, we don't know Postgres yet, but the way it's done in MySQL, you build by the second instead of by the hour.
Right. Well, we did launch per second billing for all of RDS recently. So, but yeah, it's billed by a second, but it's also not billed in the same way in that you're billed for the compute units, not for instance and storage and I/O. So it's billed a little bit differently.
And I would, so that's in public preview right now. I believe that, serverless is the future of what we're doing. It sounds really cool, right? So, and it is. Sean is the lead engineer on it, so he was giving Kevin a hard time with those questions. But I think that, what you should, if you're really interested in it, get involved in the public preview and figure out what types of applications you're doing that kind of fit that model nice and try it out, right? And we're working very hard to get it in GA soon, and then even improving it so that that scaling is as smooth as it can be, and we've got the right knobs on it, right? So it's like I wouldn't, with your most intense workload, I wouldn't plan to go GA on it next month, but it is going to be right for some workloads in GA later this year, and more and more over time. It is really a neat concept of where people think of that smooth scaling between machines. When you think of a cloud native database, it's like that and Multimaster are kind of the final, final frontiers.
The wide-eyed idealistic,
next frontiers.
the wide-eyed idealistic crazy people say that serverless is the only way people will use databases in a few years, and the whole provision model is going to go away. So,
I think it will become increasingly popular.
Right.
So you're saying stop buying reserved instances?
What's that?
So you're saying stop buying reserved instances?
Well,
maybe hold off on that for a year.
yeah.
Oh, hey, can I say something on that though? From a cost perspective, if you know what your capacity is going to be, it's still going to be cheaper to get reserved instances at this point than basically have it go up and down. That's really for a variable workload. Now that may change in the days to come, but still buy reserved instances because that's still the most economical way to go.
Yeah. For those of you who don't know, in standard provisioned RDS and Aurora, you pay for instance hours or instance seconds now. But you pay for how much you use, but then you turn your instance off and you stop paying. But most customers don't turn their databases off. You leave your database up and running, generally 24/7, 365. And so if you know you're going to do that, you can buy a reserved instance, which is a billing mechanism that will give you a discount of up to roughly 2/3 off if you buy a 3-year upfront reserved instance, which means you pay us for 3 years upfront, right? So you pay it all upfront, we'll give you 2/3 off, roughly, if you look at the pricing on our webpage. And so that's what Rich is referring to. The cost of running provisioned with a 3-year upfront reserved instance is pretty low. The pricing for serverless is, of course, designed to be very different. And if you look at it, if you have a steady state workload and you run it on serverless, it's going to be a lot more expensive than running it on provisioned with RIs. It's only when you have this really variable workload where on provision you'd have to provision for the peak, or else you're not servicing your customers well for all those peak times. And if you provision for peak and buy RIs, it's still going to be more expensive than serverless. So the pricing of serverless is designed to be cost effective for those really variable workloads, even in the face of the maxed out RIs.
Isn't there a limit when you stop the RDS instance? It said there's like a limited number of days that it can be.
Yeah, so good question. We do have a feature called stop start for RDS instances where you can stop the instance and we won't delete the storage. Because it used to be if you stopped your instance, we automatically deleted your database. Part of the reason that we didn't just make it easy for you to leave the storage around is because we're always worried about upgrades and patches and things like that. That's why we don't let you do a stop of your RDS instance for more than 7 days. Because we want you to start up the instance so that we can do whatever maintenance we might need to do under the covers, right? So that's why the limit on stopping your RDS instance is 7 days. Now, you could stop your instance and then start it up for an hour and then shut it down again. But if you can do that long term, I would question why you're doing that at all. That's where you take a snapshot and just keep the snapshot lying around. But stop start is a different way to do, it's kind of like poor man's serverless, where you have to do it manually. Your connection state is not maintained across the stop, but you might just stop your instances on Friday night and start them up Monday morning. So you're not paying for them over the weekend. That's the typical use case for RDS stop start. But it is kind of like a stepping stone to serverless. When you think it through, it's kind of designed for those similar scenarios. Other questions? Well, it is after 5 on a Monday. We've had a long day of lots of content, not just in this room. I know in other rooms. I know we've all been bouncing back and forth. We're here all week, and we've got a bunch of sessions from AWS people the rest of the week, scattered through the regular conference agenda as well. Yes. There's a question? Oh, there. Sorry.
You mentioned R-class instances. Is that typically what you run as opposed to, say, EMS or some of the more exotic?
So the question is which EC2 instance types we run. So in RDS for Postgres, we support T's, M's, and R's. T's are the smaller, less capable, but more cost-effective. And lots of customers will run their test dev QA stuff on T's. M's have more CPU less memory per CPU, so they're good for CPU-intensive workloads. And then the R's are where we typically see customers run their biggest database workloads because they have more memory and databases like memory. That's for RDS Postgres. In Aurora today, we run on the R4s and R5s. R5s in some regions, it's rolling out to the other regions, on an ongoing basis. Sorry? R5 is available for Aurora Postgres in some regions. Not in the ones you care about, I know. Not yet.
Coming soon, very soon.
Yeah, I know, it's coming. So because Aurora itself has some extra components on the database host that use memory, it's more work for us to make Aurora fit on instances with less memory. We are working on adding support for Aurora to down in the TClass instances because customers still want to run test FQA on the smallest instance they can find for Aurora as well. And so we know that that's a big ask from customers, and so it's coming. It's a lot of work to put Aurora Postgres on a memory diet to make it fit in and behave well so you can still get your workloads to work on the smaller T-class instances. The other more exotic ones, the extremely high memory instances are challenges for most databases because they're typically 4-socket NUMA machines. That means non-uniform memory access, which means that the latency to access memory that's owned by another socket in that 4-socket machine is much higher than my local memory, and it gets complicated to make high contention workloads like database workloads work well in those big memory 4-socket machines. So we haven't seen a need to go that big, because the R524XL is a 2-socket machine that scales pretty well. So, we're kind of waiting and seeing whether there's real customer demand for the really, really big memory instances. Yep. Okay. We may be tapped out. Well, thanks for coming to the last session. This has been a great set of questions. And we look forward to seeing you all week, at least some of you all week, at the rest of our sessions.